Okay, so what I did for my science fair is I did which soda beverage can stay colder the longest. Diet Coke Diet Coke or Coke. So what I did was I got 2 plastic bottles and I got 2 aluminum bottles, and I refrigerated the Coke and Diet Coke in both bottles for about probably an hour. And so once it was finished, I put the bottles up. Well, the plastic bottle first, because I wanted to do plastic. And I put thermometers in both. And I stayed there for about 30 minutes. And after that was done, I just saw what the temperature was after it was finished. And I did 3 trials of this for the plastic and aluminum, but I did plastic first. And so after the plastic was finished, I did aluminum. So I got the aluminum out of the refrigerator, and basically I just put the thermometers inside there, and I did the exact same thing. But my hypothesis was I had thought that both Diet Coke and the Coke would be the same. Actually, I think I was kind of off because the aluminum was actually, it was colder, I guess. And the independent variable was the temperature, of course. And the dependent variable was the amount of time it took to get warm. And, you know, the control group is the Cokes, of course. So, yeah.
See your abstract.
No, don't read your abstract. So you used aluminum bottle and regular plastic bottle?
Mm-hmm.
So what was your control group? Because you used 2 different types.
The
material.
Coke. The Coke.
I know Coke, but aluminum is the cans, right?
Yeah.
Cans and bottles.
Well, both. The Diet and Coke, so I didn't change anything.
So you used can for diet and bottle for diet, and then can for Coke.
No, okay, here's what I did. I put the Coke, like, what I did was like, the bottle came in for Coke and Diet Coke. I used that for plastic, and so, wait, what were you trying to say?
My question is, why did you use can and plastic? Because the cooling thing will be different. So
yes,
aluminum, the cooling content in the aluminum will be different from the cooling content. So what I'm telling you is plastic versus aluminum, the material will affect the temperature of the contents inside within. So why did you use both? Why not just stick 2 bottles for diet versus regular?
That's what I did.
So when you introduce the can in there, did you do can for both of them too?
Yeah, with the aluminum, yes.
Yeah.
Okay, and what was your independent variable?
Temperature.
What was your dependent variable?
The amount of time it took to get warm.
Which one did you change? Did you change temperature?
Well, I didn't change it. The nature changed it. Changed the temperature. That's what changed. I didn't change anything. So, the cans, I guess.
You got that right.
I changed the cans. I changed the cans.
What did you measure? Where you measured temperature, right?
Yeah.
So how can that be your independent? That would be your dependent. The time it will be your independent.
Wait, no, how? It makes no sense. Wait, it would. So what would be my independent then? that makes sense, yeah.
Time is what you manipulated.
Yeah. Yeah, you're right.
The temperature is what you measured. Result.
Okay, so that's wrong right there.
The whole thing's wrong.
That and your dependent variable.
Wait, Miss Ted, I think we should let him read his abstract. There's
Yeah.
some real emotion.
It actually makes the whole project good.
This is a project to find out which soda beverage stayed the colder the longest. I chose this topic because I originally couldn't think of anything else. Therefore, I came to no other ideas and came to Miss Barnett for help. For my choice of topic, she listed I decided to choose which soda beverage can stay the colder the longest. Coke or Diet Coke. This will obviously explain which soda beverage out of the 2 can withstand how long temperature rises or falls. My hypothesis, what I thought, both would equal the same amount of temperature drops.
But you never came and talked to me about
Yeah, I did. I couldn't think of it.
see which one stays
No, well, it was something. Yeah, you did. Yeah, you did.
Should I do that on Thursday? Yeah, whatever.
Okay, so I'm done with that. So. Okay, and for my wanted poster, which was due 2 weeks ago. Okay. All right. So shingles is basically, it kind of affects older people, not really younger people. But people over the age of 60 are 10 times more likely than children under 10. And that's a rash, not a person. I think that's a stomach or something. And diseases like HIV or AIDS. Okay, mothers who are pregnant with a record of chickenpox will make infant okay, another name for shingles is herpes zoster, and shingles can spread from contact from a rash. If crusts appear from the rash, then it is still contagious. And there is a vaccine for a herpes zoster, and it reduces incidences of shingles up to 51.3%.
If that's the stomach, what is that hand-looking extension?
That's the guy doing that. That's the hand.
How would you rate it dangerous? Is it dangerous? Rate it.
Probably 3.
How many people? What's the rate of
How many victims does it infect?
I didn't write that part. Okay, yeah, it just 25 million. I don't know. I don't know. Is that,
That's like the whole country.
is that it? Yeah.
25 seconds.